Marker. All right, and we're starting. Okay, so this is where we left off yesterday. We have a grid, and then we're dropping the dot, the spot, the little unit inside of one of these grid points. And if I put another one inside of here, maybe ones that like touch each other, I want them to properly, like, you know, I think the next part of the book is having them fight, essentially. So we have entering the battlefield, and we're actually doing that through the grid. So we have this grid add. Although we don't have it take the unit, we have it take like the X and the Y, and then it like properly passes it in. So basically the grid is essentially handling the units for us. Then let's see here. Okay, so then we're gonna have this handle melee, which is gonna go through all of the cells and then handle the cells. So I'm thinking like, I don't really have any melee or anything to work here, but what we can do is have them move around. So we can, for our grid, we want to loop through each of the, when we go through each of our cells, and I guess I could still handle cells, right? It's like an update. We probably want an update and then a draw for each of them. And I think we're kind of doing that. Draw, we're just going through all of the, let's see, number of cells. Okay, so this is drawing the grid itself. And then here, okay, so for Y cells, for X cells, and then we want to draw like these specific cells. We can do an update too, I suppose, which is gonna be very similar to this. So here's our add. Let's actually do an update. So public function update. I don't know if we're gonna mute self, but well, no, we are, because we're gonna be muting the units, and because the units are inside of the vectors, which will then be mutated. Yeah, that's gonna have to be a thing. Okay, so mute self. I don't know if we're gonna need context off the top of my head, and I don't know if we're gonna need to return a game result. So let's just not worry about that right this second. And then we're gonna have to loop through, so it's the exact same thing that we have here. And then call update on them. This will move them around, which is, I don't think, something we did in the book side of things. We're not going to do that. We're probably not gonna return that. Now it's just yelling at us that unit doesn't have an update. So let's go fix that. And what I'm thinking right now is let's just have it move to the right. And the easiest thing to do that is to say self.x plus equals 1.0. That will make it move to the right. You know, we don't have velocity, we don't have acceleration. It's not going to be like smooth. It's just going to be a static moving to the right. Unit is a, oh, right. I didn't notice that. This is inside of just a reference. So this is gonna be interesting. We're gonna have to get a mute reference out of those. I don't know if this is gonna work for that. Mute reference for that. It's not an iterator. Okay, so for X cells, in Y cells. So it's mutable, mutable. Okay, mutable unit. So I can do this now. Okay, so then we're handling this. It's claiming update's not being run. For a unit, it's a reference to a mutable reference to a unit inside of there. Oh, right, because update's not being run. That's why. So they're going to come to the main library, and inside of update, we're going to now do self.grid.update like that. And that should make that all happy. Now our dot moves to the right, but there's a problem here. It's still in this cell. It's just moving its graphics over there. So we need a way for every single frame to have it like update to its location. And that is a problem. Let's see how we handle this. Units are now stuck in their cells. If we move a unit past the boundary of the cell that contains it, units in this cell won't see it anymore, but neither will anyone else. Our battlefield is a little bit too partitioned. Yeah. So to fix that, we'll need to do a little work. Each time a unit moves, if it crosses a cell's boundary lines, we need to move it from that cell and add it to the new one. First, we'll give unit a method for changing its position. Okay, so we have this like move, which I'm having just be, I think, do I have move unit? Oh, I have move unit. I have that under update right now, so I may not need move unit exactly. If it crosses a cell's boundary lines, we need to remove it from that cell and add it to the new one. Okay, so yeah, I'm not sure that I don't think we need the unit to handle this. We update, so we call update, which is gonna like potentially change the location of our unit. I'm gonna add in the highlighter too in case anybody has any questions. Then every time we run update, so that would be back in grid here. So I update, now I want, so let's do, this will potentially, oh God, 2 L's, change the position of the unit. And then, so down here, we want to, if the unit is no longer in its correct cell, move the unit into the correct cell. That's the idea. So right here, this is where we're going to do it. So we have this add here, which is fine. And it will add something into the appropriate cell. I wonder if we should do like a remove and then an add again. Now context is creating a new unit. Ooh, and this is the reason why we probably want to take in unit here, is because I might want to remove cell. So like have something like remove in here. Like maybe get what cell it's in. All right, so let's start with like get what cell it's in. So let's do a private function. So function get cell coordinates self, and maybe we'll take a unit, which is a reference to a unit. And I'm going to return maybe, so I can return like there's so many different data structures that I could use. I could return like a tuple. So we'll just have an X and a Y. That would be like a usize. I could also have like another data structure that would have like its destination. So like where it currently is. So it's like current X, current Y, and then like next X, next Y, if it needs to move. And if that's true, then I can just like, I overbrewed my tea. It's a little bit bitter. Then the next thing I use is actually moving it, right? Like I want to then remove it and re-add it. Although I'm doing these, Bear Duda, good morning. Let's see. Yeah, okay, so if I get the cell, do I even need the cell coordinates? I just need to know if I'm in the same cell coordinates as I was here. That's what it really is, isn't it? Oh, I think I do, because I'm not actually getting the coordinates out of this, am I? I'm getting, like, I'm just looping through the units, like the actual vectors that are in there. So I don't really know where I am. I can't just say like I'm in. Well, I could enumerate through these cells, and then I'll have the Y index, and then I could have the X index, and that would give me the coordinates. I wouldn't need this at all. Perfect. I like that. That would give me the cell it's currently in. Then I need to figure out the cell, like if it's still in the same cell. Is that true? I need to figure out where are you right now? Should you still be there? If you should still be there, do nothing, right? So let's write this out. This will potentially change the position of the cell. So then, what is our current location? So as in like what cell should we be in? Although like this handles that for us with add. So maybe should we still be in this cell? Like maybe that's the appropriate question to ask here. Should we still be in this cell? And if the answer is no, remove. Okay, so if no, remove unit and re-add. If yes, then we are good. All right, I think this is the right logic here. If we go back and take a look at the book, so we have move. Yeah, okay, so see what cells in the old cell, see what cells is moving to. If it didn't change cells, we're done. So like maybe this should be like a handle moving cells, right? Like maybe we should have like a function. Function handle moving cells. Okay, so we want a mute self and a mute a unit. This is a mute unit. So here's where I was thinking about last night, and I'm not exactly sure the best way to handle this, because if I've got just a bunch of vectors and the units are sort of spread all throughout those inside of these, vectors and vectors and vectors, how do I know which unit to pull out? We're passing by reference, so we can just see, hey, go until I get it. I guess if I have a mutable reference to this unit, I'm not going to be able to, with a mutable reference to this unit, also take a mutable reference to this music. See, what station am I at right now? I'm on EDM station. Let me change that around to, that's down here. Maybe synthwave? All right, got it. Where's synthwave? There it is. I have it set up to not play lyrics. So anyways, regardless of what we choose, it should be good. Holiday? Maybe someday. Okay, anyways, back to this. I don't think we're going to be able to do this as a mutable unit, because I'm going to need now a mutable reference to the unit and a mutable reference to the array that holds the unit. I can't imagine this is going to work out very well. We can try it, but I think what would be better is if I get access to the units X and Y and the ID. So here's what I think I'm going to have to do. I think I'm going to have to store an ID inside of the unit. And then that way I can go through those inner vectors for each cell and just check, hey, are you are you supposed to be in here? If you are, go in, find the unit with that ID, and then remove it. Like, get the index of it and remove it. And then add it in back again into the grid. I think that's what we're going to want to do. Let's see. Okay, so handle moving cells. So we could try this. I think it's going to end in tiers, though. So if we take in a mutable reference to this unit, does it need to be mutable reference to the unit? I don't think it does. I think it could just be a reference to the unit. Because I'm not going to be changing the unit at all. I'm going to be changing self. Okay. Now, I need to recalculate where we're supposed to be. Well, we have that right here, this calculation. So if I copy you, here's the cell X it should be. And we can call this maybe old cell X, old cell Y. Equals, and so this is going to be the unit dot X, and then the unit dot Y. Are you yelling at me because you're private? Yeah, you're yelling at me because you're private. So let's make this public. Okay, so that'll make you happy again. We have where it was supposed to be. Actually, this is not true. This is where it's going to be, because this is after it's moved, isn't it? This is going to be the new cell. How do we find the old cell again? Okay, see what cell it was in. And see what cell it's moving to. Oh, we're handling that there. So as we move, so this is almost as if the, oh, okay, I get it. That's why they're gonna have the unit called grid to move it. Because it wants to like handle this moving in a cell before we move that. And if I want to do that, okay, so I don't think this is going to work very well. If I try to like handle some kind of move, let's say I did this. Let's say I did like public function handle move. Hello, Chantilly. I'm going to have like a mute self. And then also a grid, which is a mutable reference to a grid, which I don't think this is aware of. Yeah, I would have to pull this in to use super grid. Okay, so you're not terribly upset at this yet. Although probably because it doesn't know that it's the same grid that it itself lives in. Now, all this was planning on doing was in update. I guess it would be part of this update, wouldn't it? Yeah, it would be like this. You get a grid, which is a mutable reference to grid. Before we run self like plus x equals 1, we would want to essentially do like our intended move, right? Like what's the intended move that we want to do? So like let new x equals self.x plus 1.0. Let new y equals self.y. We can just do that. Like we're not moving you, we're just moving to the right. So then we're gonna want to call into grid this like handle moving cells. So make you public, take in the unit, and then take in the x, which is an F32, and a y, which is an F32. So hold on, we'll redo this in a second. So if I save you and then unit update, you want to take in a reference to the grid. So here's where everything is going to fall apart. I'm not going to be able to say self here, I don't believe, because this is going to say, hey, you can't borrow a self as mutable more than once at a time. And I don't think I can do anything like weird dereference or like passing crazy references to it. It's already borrowed as mutable here, so I can't do it again. And like maybe I can pass in a reference to like handle moving cells. But again, like that would cause a problem. So I'm thinking we're gonna have unit update, instead of like passing a reference to itself and then having that handle it all, what if we have unit to update return its intended move? Because we can still update that. Because down here we see unit, yeah, we update unit here from the grid. So if we call a grid move, then we're going to want the old X and Y and the new X and Y. And that's all we need to be able to calculate what cell it should be in, remove it from the cell, and add it to the new cell. That's all we need. So I'm thinking we want, back to here, we're not going to take in this. We're going to return something. So I could do something like return old X and Y and new X and Y. So I can do something really weird, like I can do a tuple of tuples, right? I can do like old and new. But if I always have an old and a new, sort of like some kind of like move, what if I did that as a struct? So let's create a new file in here, and we're gonna call this our like intended move struct, or how about like moving? Like maybe unit moving. Unit moving.rs. In our main library, we don't really care about this here, do we? We care about it in unit, excuse me, and grid. However, library should probably be aware of it so it can publicly like just move that around. So we're gonna mod unit moving, just like that. Nothing else I don't think we need to care about. So here we're gonna do a pub struct unit moving. And I think we're gonna want a an old X, which is an F32, old Y, which is an F32, new X, F32, new Y, which is an F32. So we can use this data structure here. And we can even create, like we just implement and create a new off of this. So implement unit moving, function new. So we're gonna take old X, F32, old Y, F32, old new X, F32, new Y, F32. We're going to return a unit moving. And so then we're just going to return unit moving, old X, old Y, new X, new Y. So if we have something very, very like just simple like that, inside of unit here, let's go ahead and use super grid. We also want to use super, what do I call this? Unit moving, unit moving. And here we're going to return a unit moving. So before we create this, let's actually figure out what this is. So we're gonna let unit moving equals unit moving new. All right, so we're gonna have our old X, which is our current one, right? So like self.x, self.y, and then our new X is gonna be like what we're figuring out here. So that's gonna be our self.x plus 1.0, and then we're not moving at all, so this is going to be self.y again. Save that. Then we actually do the move, right? So we do this move, and then we are going to return unit moving. Back into the grid. So let unit moving, well, we're going to need to know what type this is, I believe. It should yell at us. So unit moving equals, or no, you just sort of figure that out. Cool. So now we have this unit moving here. So we can grab the old X and the old Y, and so we can now handle moving cells. And instead of passing in this unit, which I still think we're gonna have the problem when we actually try to take the unit out, we don't know exactly what it is. But at this point in time, we can now figure out, should we move you? And if no, we're good to go then. Okay, so we have, we deal with this. Let's go ahead and handle moving cells. And we're gonna pass in a unit moving. Here, we are going to have to pass in use super unit moving. Okay, so we're gonna take ownership of this, which is fine. We just want this to die pretty quickly and, stop taking up any memory. We have the old X and the old Y at this point in time. What we really need is like the actual old X, like the cell, like where it really was. So maybe we can do let old X equals unit moving dot old X, and it's going to be this, right? As U size divided by cell size. As U size divided by cell size. So that gives us the actual like X coordinate that's supposed to be in. Now you're yelling at me because it's not public, so let's fix that. So pub. So let old Y equals unit moving dot old Y as U size divided by cell size. Okay, so that gives us this. Let's figure out what the new one is. So that new X equals unit moving dot new X as U size divided by cell size. Okay, so unit moving dot new Y as U size divided by cell size. Okay. Now, if they're the same, like if we're supposed to be in the same cell, we're done, and we can leave, like we can end. So we can just say if old X is equal to new X and old Y is equal to new Y, then we can just return. We're good. However, if we get past this point, it's time for us to move cells, which means we now need to remove ourselves from the cell. And so here we come with another problem. How do we know which one we are? Previously in the book, we have a reference to ourselves. So we can just check equality. Is the reference to us where we actually are in memory? We don't have that anymore. So we're gonna have to have like an ID count as we go in. So we need some kind of ID system. So let's, every time we add in a unit, let's give it an ID. So that'll be here in unit. We'll have an ID, and we can make this like a U64. It really depends on how many of these we expect to have. U64 would allow us to have a lot of units. And then we're gonna pass that in here. So an ID, which is a U64, and then we'll take that in here. We're also gonna need to make this public so that we can get access to it later in the grid. Now, we want the, so like the next ID is going to be a U64. And in new, I don't think we need to do anything crazy here. We can just do let next ID equals 0 and store that in here. Then when we add, we're going to pass in the ID. So self.nextID, and then we have to remember to self.nextID plus equals to 1. There you go, a unique ID per unit. Which means that when we handle moving cells, we're also going to need to know its ID. But I think we can handle this by adding that to here. So the unit moving, and we're going to have the unit, so pub unit ID, which is a U64. We'll add that in here. So the ID, which is a U64. I might as well just call this the unit ID. And then the unit ID. Okay, so now I'm gonna have access. I guess when the unit creates this, we need to pass in our own ID. So this is gonna be self.id right there. And that makes you happy. Back to grid now. Okay, so we reached this point. Now it's time for us to remove ourselves from the grid. And we know the X that we're on because it's the old X and the old Y. So I can go there pretty easily. We can say self.grid, self.cells dot position. So it's the Y first, so old Y. And then inside of that, we have the old X. And then now we have the vector of the units. And so now we have to like somehow like remove, filter. There is a way to do this in place, isn't there? It's like, is there a remove? So removes and returns the element at position index within the vector, shifting all elements after it to the right. Well, that's a problem. I don't know its index. Removes the first instance of item from the vector if it exists. If I had a reference to the unit, I could do this. I might have to like find it and then remove it. Retains only the elements specified by the predicate. Is there an opposite of retain? In other words, remove all elements E such that FE returns false. This method operates in place, visiting each element exactly once in original order and preserves the order of the retained elements. The exact order may be useful for tracking external state, like an index. Let's see, what else do we have? Yeah, okay. So if I had the index in the vector, that would work really well. I don't. I have an ID of the unit. So I have this. I could remove item, but it sounds like maybe this retain is best. I don't see like a filter. So if we look at retain, wait, do we have? I didn't realize, I forgot that I had like typed RE first, so I was not looking at everything that we could look through. So let's see, batch, probably don't want chunks. So there's contains, returns true if the slice contains the given value, but that's not exactly right. Okay, there's drain filter. So creates an iterator which uses a closure to determine if an element should be removed. If the closure returns true, then the element is removed and yielded. If the closure returns false, the element will remain in the vector and will not be yielded by the... Okay, so this might be what I want. If the closure returns true, then the element is removed and yielded. So if I do something like this, then we're gonna say let unit equals. Inside of this filter, we're gonna have this, and we're gonna take in the unit, which is a mutable reference to the unit, and I want to return if the unit dot ID, if that is equal to unit moving dot ID. So what are we upset about? Let's do this one first. No, oh right, it's unit ID. Okay, and then U creates an iterator. Oh wait, no, is this nightly only? Use of unstable library feature drain filter recently added. Oh, it's nightly, isn't it? That would have been so nice. This would be so nice. Because it would have done it, and given me exactly what I wanted. But I don't think I can do this. All right, what else? What else is available to us? Draw. Let's see. There's get. Probably not what we want. We can turn into an iterator and then like essentially mutate off of that. Then we can just filter. And maybe that will work. We do need to get the unit out of it. So we do need to like find, we're gonna need to find the unit first. Remove and returns element of position index. So it sounds like what we're gonna need to do is find the unit first, find what index it's at. Then we can remove the item, which will give us ownership back. It'll remove it, and then we can re-add it. I think that's what we're gonna have to do. I just don't see any other way. Just a little bit sad. Okay, so with find, is there a dot find? No, there is not. So we're gonna have to search through and give. We can put it into an iterate, right? Like we can turn it into an iter. Is there a strong reason you don't have the unit reference available to you here, stored in the unit mother? Yeah, we could try it. I wasn't sure if I could put. Oh no, I can't put the unit unit reference here because unit moving is creating that. So handle moving cells. That's happening. Oh, I don't have it like actually created, like being called at this point in time. Hold on. If we do this right here, this unit moving, okay, yeah, here's what I can do. So unit moving, and then also the unit, which is, I probably don't need it to be, I could just make it a reference to the unit. Then we'll call it from here. I'll have access to it. Then maybe I can do that find and remove, can't I? So what is it? Dot. What was it? Was it remove? Removes and returns the element of position index. Remove item. Removes the first instance of item from the vector if the item exists, and we can pass that in. So if I do remove item and pass it unit. We get a unit, which is an option that holds a unit. Unstable library feature, recently added. Well, that's a problem. It's a little bit sad. Okay, so that doesn't help me. Unless I like switch to nightly or something. So many nice things that are like coming that aren't here yet. And of course, can't compare unit with, so I would need to implement partial equal. That's not like terribly hard. I can just do like a derive with that. It's just gonna yell at me about like, hey, you're not really added. Which is a little bit unfortunate. Okay, so now I have a better solution instead of like beating my head around this. For these cells, what I have is like this outside vector, which is the Y, and then the X, and then here, just a vector of all the units inside of it. I don't actually know if it's necessary for me to have this be a vector. What if I have this be a hash map, and then I can have ID as the key, and then the value is the unit? If I do that, then I can just reach in and grab the unit out, and it'll be really easily. And there's still abilities to iterate through hash maps. So why not? I think that would be the best way to do this, is not use a vector. So let's use standard, I think it's like collections hash map. And so inside of here, instead of vector, 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 we're gonna do vector, vector, hash map. And then the ID is gonna be a U64. And then the value is going to be a unit. Like that. Now when we create this entire thing, it's cells. Let's see, where is cells? We're going to push this empty vector here. We're going to push actually a hash map new, like that. And so that's going to make that happy. Now, when we go into insert into here, oh, like draw is also going to be upset about this. So this is where we need our iterator through. So we have Y cells, X cells, for unit in XLs. Right, so this is the inner. Okay, so this is giving us all the cells. This is actually the X cells, isn't it? Like this is the X row that we're looking through, whereas this is the Y row. Then these are all of the hash maps. Yeah, okay, so this is the hash map. And this is a U64 in unit. Okay, so let's change this up a little bit. So this is the Y. This is actually the X cells. And is it really X cells, or this is really like the X row? And now, okay, so here is our hash map. So you are going to be like all of the units. Now, if I want to loop through here, so units, this is going to be a tuple of the unit ID and then the unit. And then I can say unit.draw and pass in the context. So you're happy again. All right, back onto this. In add, so self.cells, cell Y, cell X, and then we're not going to push. Now we're going to insert. And it's two things, right? We insert the key and the value. Yeah, okay, so the key and the value, it's going to be we don't want to increment the ID until the very end, so that way we know what it is. Or I could just do unit.id. That's fine too. And then we want the unit itself. Okay, we have that here. Update, same thing. We're going to start with, we have the Y row. The row here. And then the X rows, well, this is really our units. This is our tuple of ID. So unit ID, and then also the unit. And then, okay, so let unit moving equals unit.update. So now we know where it's moving to, and we have the unit itself. And it's a mutable reference to the unit. Now, what's interesting is, do I want to do this here and like have it move the like cells, or do I want like everything to post or move and like have a vector of maybe our moves, and then handle all the moves after that? What I mean by that is, what if I do something like this? Let unit moves equals an empty vector. I make this mutable, and then instead of like holding this here, I just do unit moves dot push unit dot update, like that. And so now I have all of these unit moves here. At the end of this for loop, I can now call handle moving cells and like pass it the array of the vector of these unit moves, and then just do them to occur like all at once. I don't know what the best idea for this is. I'm gonna leave this commented out just in case I need to go back to it. Let's try just doing it as needed. Okay, so we'll do let unit move equals unit dot update. Okay, so we do that. So we have unit moving. Then we're going to call self dot handle moving cells. Hand it the unit move, and then hand it a reference to the unit. I don't need this anymore, is there? Because I have the ID of the unit. So I don't need you. I have the ID inside of unit moving. Now removing this should be really, really, really easy. I should be able to say dot. Is there? Let's see. There's remove. Removes a key from the map, returning the value at the key if the key was previously in the map. So I can just do remove and unit moving dot unit ID, like that. And that gives me an option of this unit. What are you upset about? Expected a reference to U64. Okay, so let's give you a reference to that. All right, that's super. That's so much easier. So now we have, and this is all like really fast. We don't have to like iterate through once again to find it in that vector. We just go straight to where it is and grab it. So here's this unit. We now want to re-add this into the cells. So this one is also pretty simple. We know exactly where it should go, don't we? We're now going to put it into its appropriate spot. So it's going to be self.cells of new y, new x, dot insert. The key is going to be the unit dot ID, and the value is going to be the unit. Now this is an option, right? So this can only happen if we have the unit, which should always happen, but we should like be really careful with this. So if let sum unit equals unit, then we do this. Self.cells, do this, and then pass in the unit, and everything should be happy. And the unit's already moved. So I think this handles it. What other errors do we have? I see red here. Right here. Okay, so self, that handle moving cells. What are you upset about? Cannot borrow self as mutable more than once at a time. Okay, yeah, so because this needs a mutable self, and we're in mutable self right here. Yeah, I do see that that's a problem. Now, oh, I do need this to be mutable, I think. Because if I try to make this just not mutable here, then we were not going to be able to get a mutable out of here. So that is a problem. I can try to go back to this way and maybe call. It's like self.moving cells. So if I move you down here, outside of the for loop, then unit move, I would want you to be like an array or a vector of these unit moves. So I would like back to this. Then we can say unit moves dot push unit move. Guess I don't need that. I don't need any of you. I would want to pass in unit moves, which of course is going to make this upset. These are going to be unit moves, which is going to be a vector of unit moving. And then I need to iterate over these. So for unit moving in unit moves, and then move you all the way down here. Can I find value unit moves? It's right here. It's right there. Unit moving, spatial, the syntax error, expected a comma. Or how about closing that? There we go. And now it's happy. So that was the problem. I was inside, like I had borrowed cells here, and I had borrowed self here. So basically I had these two mute, so I have to do this at the end and like handle them all at the same time. Which is like, it's fine. Now if we run this, nothing should really change running wise. We have a debug running there and you aren't moving. Are we actually moving it? I forget. Let's see. So we're call unit.update in unit. When we do update, oh, we have this new x, new y. We forgot to do self.x equals new x. So hold on. We have unit moving. So we're passing all of this stuff in here. It's like old is self.x, self.y. The new is self.x, self.y. I don't want these anymore. I would want to just reach in and just say, hey, self.x equals unit moving, just to make sure I'm consistent, dot new x. Self.y equals unit moving dot new y. So if I do that, let's make sure that this works. Okay, so everything moves. Theoretically, it's moving into a different grid here. So how can I prove that it's a different grid? When I remove it, I could give it a different color. So this is something I was also thinking about last night. As it moves the grids, maybe we can like change its color. So if we have this like this unit and we store color inside of here, we have this public, and then when we remove the unit and handle movement cells, we can now assign it a new color to show that it's moved into a grid cell. So we could do that. And then I can have it like just randomly generate a color maybe every time. Like it would be really cool if I could just assign a color per grid, like per cell as well. I don't necessarily have, I don't have an easy way to do that right now because I don't have like, cells is not a struct. I could definitely make cells a struct, and then I would then like store that and it would wrap around this hash map. I mean, that might be something interesting. Let's have it for right now. Generate and like create a new random number generator. So maybe in the full library, let's go into here and let's pull in rand. In our main library, we will use rand prelude star. We're going to hold RNG, which is a thread range. Let RNG equals, I think, I always forget. I think it's let RNG like that, and then store this in here. All right, so now this is available to us. In grid.update, we're gonna pass this in. So self.rng. You might need to be mutable, I can't remember. So in grid, in update, well, we're gonna need to take in, so use rand thread RNG. So RNG, which is mutable, right? Because I don't want it to be like take ownership of it. I want it to be a mutable reference because I don't think I can do a reference to a thread range. We can try. Handle moving cells, so we can just pass this on through. RNG. So RNG is a reference to thread range. And then here, let unit. So if we reach this point, now we need a random color. So let random color equals, we need to create that in here. So graphics, color. So color new. All right, so R, we're gonna do a rng.gen range between 0.0 and 1.0. rng.gen range 0.0, 1.0. rng.gen range 0.0, 1.0, and always full like that. And then unit.color equals random color. Now no field on you, so we're gonna go up into units. We're gonna store color in here. And you are a color. Let's start you as white. So we know that color, we're just gonna make you white to begin with. Well, I guess I don't have you in here. Let's bring in white. Okay, so that gives us that. We need to store the color. So here is this color being set as white, which means that when we draw you in our draw params, we're now going to be able to do dot color and then self dot color, and sort of like overwrite it there. And I think it's actually additive. So it starts as white, but then we add like red to it, but red plus white is just red. Okay, and so I think that works. Our color is gonna have to be public, so it can be accessible elsewhere. Let's see, unresolved import, thread range, no thread range in a root. I forget where it is. I could just do thread range that way. No method dim range found for this. I might as well just bring in everything since I don't remember what everything I need is. No field color on standard option. Right, so we need to set you inside of here. Mismatch types expected, ran thread range, found struct, RNG's thread range. Oh, a reference. Okay. Okay, cannot borrow RNG as mutable. So you need to be mutable. Okay, so you need to be mutable, which means you need to be mutable, which means you need to be mutable. Can assign to unit color. Okay, so you need to be a mute. Can I do this? Unit, yes. No errors. All right. Let's see if every time that we change cells, our there it goes. As soon as it changes cells, it changes colors, which is showing that it actually is changing cells. Like it's gone. Wait a second. That wasn't me quitting. That was an error. Right, because as soon as it left this this arena, that's a problem. It tries to leave the arena, but there's no grid for it to go to. So that's a problem. We would need to handle that and basically say, you can't leave the arena. You're there forever. The best thing to do would be just to have it like bounce and move around. Now, if I wanted to like take the random moving like a little bit further, I could have it actually just like randomly walk around, and that would be fine. Instead of unit here in update, we can just take in RNG. So let's go ahead and use that. Use rand prelude star like that. We'll have RNG, which is a mutable reference to thread range. So instead of this, let's do, I think it actually would be easier for us to do let new x equals, and this is going to be the old x, so self.x plus rng.gen range between -1.0 and 1.0, and let new y equals self.y plus rng.gen range between -1.0 and 1.0. Okay, so those are gonna sort of move around randomly in unit moving. So you are now gonna be the new x. So new x, you will be the new y. And then also we'll have, so old x, old y, new x is actually gonna be the new x. The new y is just gonna be new y. And then the unit ID. Okay, and then we return that. That should be fine there. There's 3 errors, and that's because I'm not passing in the RNG. So I think I can just do RNG here. It's already borrowed as mutable. No errors. Let's see if this moves around randomly now. It does. And if we see it move across cell lines, it should change color too. Probably would be better for me to like add in some kind of like velocity and acceleration for when it like handles that. And then I want to like have them eat each other. So that way if they like cover each other, which we can do by checking inside of the cells for combat essentially. But we may have to do that next time because we're running a little bit late this morning. So you're not really all that exciting. You know what I can do in the meantime? So we have this pub x and y. We can do, let's see. This won't be public, This can be just private with, we're gonna have a velocity. So velocity x, which is an F32, velocity y, which is an F32, acceleration x, which is an F32, acceleration y, which is an F32. So if I do that, you all are starting as zeros. So if I just do velocity x, 0, dot 0, velocity y, 0, dot 0, acceleration x is 0, dot 0, acceleration y is 0, dot 0. Okay, so starting you all off with like no movement whatsoever. When we update, we're gonna want to increase our acceleration by some amount. And actually, you know what? I probably don't need the acceleration, do I? That's if I like was having multiple forces. We could just have a velocity. That should be fine. So in our update, I actually want to randomly add to our velocity and sort of change that around. So let's self.velocity x plus equals, and it's going to be this RNG.genRange. That's what's going to happen here. Self.velocity y plus equals to u. Now our new x is going to be self.x plus our velocity x, so self.velocity x. And this will be self.velocity y. And then everything else should remain the same. And now it should be much smoother and moving around. And now we get much like faster movement. I'm actually surprised that that didn't cause... Oh wait, do we have a U8 here? I think we're using U8s for the cells, and that's why we can't move to the right of it, because we only have eight of these. But to the left would crash it because it goes below 0. Although dividing won't get us 0, it'll just be 0. Out of balance, the length is 8, but the index is 8. Yeah, okay. So I would need to also handle connecting with the edges and like stopping it, like maybe balancing it off. And that could be done like here in update, where I would need some, it would need to be aware of the like edges of the world. Which probably could do by passing in context. We'll get the drawable size, and then we can, you know, stop that. But it is 8:17, which does mean that I have to sort of wind the stream down. So what I'm gonna do is close all of these up, open up, get Kraken, and I'm gonna push this code on up so you can all see it. So stage U, and we're gonna have units are changing cells and moving around the arena. And push U on up. I have a link to this in Bang repo. Get going! Yeah, absolutely. Feel free to go take a look at that. I have done accepted pull requests in the past, so if you find a problem with my code, or you just want to sort of like add any kind of interesting features to it, absolutely, please open up an issue, comment on it, show me what you do. That would be interesting. And you can reach me on Twitter. I have a link to that down below, or I have a bot command for that, or you can follow me here for notifications for when I go live. And so with that, I'm going to switch to the ending screen, and I shall see you next time. Have a great rest of your day, or the end of your day. And I will see you hopefully tomorrow, and if not, then Monday probably. All right, bye.